ExpressRoute Direct Overview. ExpressRoute Direct provides dedicated physical connectivity directly to Microsoft Edge locations without service provider intermediaries. This enables provisioning multiple ExpressRoute circuits on demand with flexible bandwidth allocation. Key technical advantages include dedicated fiber optic connections, sub-rate circuit provisioning, dual-port redundancy, and direct BGP peering with Microsoft's backbone infrastructure. Supports 10 gigabits per second and 100 gigabits per second port speeds with the ability to create multiple circuits per port pair, each with independent bandwidth requirements and routing policies. Direct fiber connectivity terminates at Microsoft Edge Exchange locations, using single-mode fiber optics. Each ExpressRoute Direct deployment requires dual physical connections for redundancy. The architecture separates physical layer connectivity from logical circuit provisioning. Physical ports provide raw bandwidth, while circuits handle traffic segmentation and routing policies. Cross-connect infrastructure links customer equipment to Microsoft Edge routers through dedicated patch panels and fiber management systems. Bandwidth configuration. Port speeds of 10 gigabits per second support circuits from 50 megabits per second to 10 gigabits per second. The 100 gigabits per second option supports circuits from 50 megabits per second to 100 gigabits per second, with higher circuit density per port pair. Sub-rate circuits enable bandwidth optimization across multiple workloads. Circuit bandwidth can be modified post-deployment without physical infrastructure changes. Each circuit operates independently with separate BGP sessions, ASN assignments, and routing policies. Technical requirements. The AZ account show command verifies the current subscription context and user permissions. The AZ provider show command checks the Microsoft Network Provider registration status required for ExpressRoute resources. The AZ Network ExpressRoute port list command validates ExpressRoute Direct quota availability in your subscription. Physical requirements include single-mode fiber infrastructure and compatible optics. Network requirements include an assigned public ASN, an IP addressing plan for BGP peering, and routing policies for traffic engineering. Planning considerations. Capacity planning involves analyzing current and projected bandwidth requirements across all circuits. Consider burst capacity, growth patterns, and redundancy requirements. Design considerations include BGP routing policies, traffic engineering, failover scenarios, and integration with existing network architecture. Location selection depends on latency requirements, physical connectivity options, and Microsoft Edge presence in target regions. ExpressRoute Direct Resource Creation. The AZ Network ExpressRoute port create command provisions the ExpressRoute Direct resource. The name parameter sets the resource identifier, while location specifies the Azure region for resource placement. The bandwidth parameter sets port speed, 10 or 100, in gigabits per second and directly impacts monthly costs. The encapsulation.1q parameter configures standard 802.1q VLAN tagging for circuit isolation. The peering location parameter determines which Microsoft Edge facility hosts your physical ports. This is where your fiber will terminate, such as Seattle. The AZ Network ExpressRoute port show command retrieves port status. The query parameter filters output to show admin state and operational status for monitoring deployment progress. Physical cross-connection setup. During physical cross-connection setup, the AZ Network ExpressRoute port show command, using the query parameter, monitors physical layer status. This query, selecting fields like link name, operational status, and RX light level, shows the status of both primary and secondary links. After physical cross-connect completion, the AZ Network ExpressRoute port update command, with the admin state parameter set to enabled, activates the ports. This administrative control prevents premature activation before the fiber is installed. The RX light level values indicate the optical power reception, measured in dBm. For healthy fiber connections, these values typically show between -10 and -1 dBm. Circuit creation on direct ports. The AZ Network Express Route Create command is used to provision circuits on ExpressRoute Direct ports. The name parameter sets the circuit identifier, while peering location must match the direct port location. The bandwidth parameter sets circuit capacity in megabits per second. For example, 2000 megabits per second equals 2 gigabits per second. The provider Microsoft parameter indicates usage of a direct port rather than connecting through a service provider circuit. The Express Route Port parameter links the circuit to a specific direct port resource using the full resource path. The AZ Network Express Route Update command assigns VLAN IDs using set Express Route Port links 0.VLAN ID equals 100. The AZ Network Express Route Show command verifies the circuit provisioning state and bandwidth allocation to confirm successful provisioning. BGP configuration and basic routing. The AZ Network Express Route Peering Create command establishes BGP sessions. The peering type Azure Private Peering parameter enables VNet connectivity, while the peer ASN parameter sets your organization's BGP ASN, such as 65001. The primary peer subnet and secondary peer subnet parameters define /30 point-to-point networks for BGP neighbors. The VLAN ID parameter must match circuit VLAN assignments. The shared key parameter provides MD5 authentication for BGP session security. For Microsoft peering, the advertised public prefixes parameter lists your public IP ranges advertised to Microsoft's network. Microsoft peering requires public IP addresses and supports Office 365 connectivity through the peering type Microsoft peering parameter. Advanced Multi-Circuit BGP Setup. The AZ Network Express Route Peering Update command applies route filters to existing BGP peerings. The route filter parameter references a route filter resource that controls which Microsoft service prefixes are advertised over Microsoft peering. The AZ Network Route Filter Create command builds service-specific filters using rules parameter with JSON syntax. The community's value 12076:5010 targets Exchange Online services for selective routing control. The AZ Network Route Filter Rule Create command adds additional filtering rules to existing filters. The community's parameter accepts Microsoft's predefined community values for specific services, like SharePoint, which uses the value 12076:5020. Route filters enable granular control over which Microsoft 365 services are accessible through each circuit, allowing traffic engineering and security policies at the Azure service level. Virtual Network Gateway Integration. The AZ Network VNet Gateway Create command provisions ExpressRoute gateways. The gateway type ExpressRoute parameter specifies gateway function, while the SKU determines performance characteristics including bandwidth limits and maximum connections. The public IP addresses parameter accepts multiple public IPs for active-active gateway configurations. The ERGW3AZ SKU provides zone redundancy, highest performance, and fast path support for bypassing gateway processing. The AZ Network VPN connection Create command links gateways to circuits. The Express Route Circuit 2 parameter references the circuit resource ID, while the routing weight controls traffic distribution across multiple circuits. Higher routing weight values receive proportionally more traffic in active-active scenarios. The AZ Network VPN connection update command with enable fastpath true bypasses gateway data plane processing for improved performance. Route Advertisement Management. The AZ Network Route Filter Rule Create command builds service-specific filters. The access allow parameter permits matching traffic, while the route filter rule type community parameter enables BGP community-based filtering for Microsoft services. The community's parameter accepts Microsoft's predefined community values like 120765010 for Exchange Online. Multiple rules can target different services within the same filter for granular control. The AZ Network Express Route Peering Update command applies route filters to Microsoft peering using the route filter parameter. This controls which Azure service prefixes are advertised over the BGP session. Route filtering enables security policies by limiting service access scope, and provides traffic engineering capabilities by controlling which services are reachable through specific circuits. High availability configuration. The AZ Network VPN connection create commands with different routing weight values create weighted load balancing. A weight of 200 for primary and 100 for secondary creates 2-to-1 traffic distribution across redundant circuits. Zone redundant gateways using ERGW3AZSKU automatically distribute across availability zones without additional configuration. This provides protection against data center level failures with automatic failover. Multiple circuits across different Microsoft Edge locations provide geographic redundancy. Each circuit operates independently with separate BGP sessions and can fail over without affecting other circuits. Connection monitoring and health probes ensure rapid detection of circuit failures, enabling automatic traffic redirection to backup paths within seconds of failure detection. Traffic Engineering Advanced. The AZ Network Route Filter Rule Create command with different communities values enables service-specific traffic policies. Using 12076:5010 for Exchange Online and 12076:5020 for SharePoint allows independent routing control. The access parameter controls whether specific services are permitted or denied through each circuit. Combined with multiple circuits, this creates sophisticated traffic engineering scenarios. Multiple route filters can be applied to different circuits, enabling scenarios where critical services use primary circuits while less critical services use backup circuits or internet breakout. Dynamic route filter updates using AZ Network Route Filter Rule commands allow real-time traffic engineering without circuit disruption or BGP session resets. Security and access control. The AZ Network Private Endpoint Create command establishes private connectivity to Azure PaaS services. The Group ID blob parameter specifies the storage service type, and the Private Connection Resource ID references the target storage account. The AZ Network Private DNS Zone Create command builds private DNS resolution for private endpoints. The zone name privatelink.blob.core.windows.net enables proper name resolution for private endpoint connections. The AZ Network NSG Rule Create command defines traffic filtering rules. The source address prefixes parameter accepts CIDR blocks, and the destination port ranges controls allowed ports for granular security control. The AZ Network Route Table Route Create command with the next hop type virtual network gateway forces traffic through express route rather than internet paths, implementing forced tunneling for security compliance. Monitoring and diagnostics. The AZ Network Watcher Connection Monitor Create command establishes end-to-end connectivity testing. The source resource and dest resource parameters define test endpoints, while dest port specifies application ports for realistic testing. The AZ Monitor Diagnostic Settings Create command enables metrics collection. The workspace parameter targets log analytics for centralized logging, while the metrics array configures which performance counters to collect. The Enable AZ Network Watcher Extension PowerShell command deploys monitoring agents to virtual machines. Network Performance Monitor requires agents on both source and destination endpoints for accurate bidirectional measurement. KQL queries in log analytics use BGP route table to analyze routing changes. The bin function aggregates data into time intervals, while render time chart creates visual representations of route stability and convergence events. Performance optimization. The AZ Network VPN Connection Update command, using the Enable FastPath True parameter, bypasses gateway processing for supported traffic flows. FastPath requires Ultra Performance or ERGW3AZ Gateway SKUs and eliminates gateway latency. Windows Netshish commands optimize TCP stack behavior for high throughput scenarios. The autotuning level equals normal parameter enables automatic window scaling, while chimney equals enabled activates TCP offload engine capabilities. Linux sysctl parameters configure kernel network buffers for optimal throughput. The net.core.rmem_max setting defines maximum receive buffer size, while TCP_RMEM configures dynamic buffer scaling from minimum to maximum values. Quality of service policies using policy map configurations allocate link capacity with priority queuing for critical traffic and bandwidth guarantees for different service classes, ensuring optimal application performance. Troubleshooting methodology. The AZ Network Express Route Port Show command, using the query parameter, filters output to essential diagnostic information. The RX light level field indicates optical power reception. Values below -15 dBm suggest physical connectivity issues. The AZ Network Express Route Show command displays circuit provisioning state and BGP session status. The query parameter can filter to specific fields like circuit provisioning state and service provider provisioning state. The AZ Network Watcher Packet Capture Create command enables traffic analysis, with the filters parameter accepting JSON arrays specifying protocol, ports, and direction for targeted packet collection and analysis. Network Testing Tools integration with Azure Monitoring provides comprehensive diagnostics from physical layer through application performance, enabling systematic troubleshooting methodology. Automation and infrastructure as code. The ARM Template Properties section defines ExpressRoute Direct configuration declaratively. The bandwidth in gigabits per second property sets port speed, while peering location determines the Microsoft Edge facility for physical connectivity. Bicep syntax simplifies template authoring with strong typing and IntelliSense support. The resource declaration uses Microsoft.network/express route ports resource type with API version specifying feature compatibility and supported parameters. Terraform AZURERM_express_route_port resource enables multi-cloud deployments with consistent syntax. The Link 1 and Link 2 blocks configure dual physical connections with admin_enabled controlling port activation state. PowerShell new-AZ express route port commandlet uses parameter splatting for readable configuration. The @params hashtable technique improves script maintainability and enables parameter validation and reuse across deployments. Migration and transition strategies. The AZ Network Express Route Create command with the Express Route Port parameter creates circuits on direct ports for parallel deployment. Initial lower routing weight values minimize traffic impact during testing phases. The AZ Network VPN Connection Update command enables gradual traffic migration by adjusting routing weights. Increasing weight from 50 to 150 shifts traffic preference without complete cutover, allowing validation at each step. The AZ Network VPN Connection Delete command safely removes legacy connections after successful migration validation. The no-wait parameter enables asynchronous deletion without blocking subsequent operations. Migration validation using AZ Network Watcher Connection Monitor commands confirms end-to-end connectivity before decommissioning legacy infrastructure, ensuring zero downtime transitions with rollback capabilities. ExpressRoute Global Reach. The AZ Network Express Route Peering Connection Create command establishes global reach connections between ExpressRoute circuits. The peer circuit parameter references the remote circuit resource ID, enabling direct connectivity between on-premises locations. The address prefix parameter defines the /29 subnet for the global reach connection. This subnet must not overlap with existing address spaces and provides point-to-point connectivity between circuits. The AZ Network Express Route Peering Connection Show command monitors global reach connection status. The connection state field indicates whether the connection is successfully established and operational. Global Reach enables optimized routing between on-premises sites through Microsoft's global backbone, bypassing internet paths and providing consistent performance characteristics. Multi-region deployment. The AZ Network Express Route Port Create Command provisions ExpressRoute Direct in multiple Azure regions. Each region requires separate port provisioning with region-specific peering locations and bandwidth allocations. The AZ Network VNet Gateway Create Command deploys gateways across regions with consistent SKU configurations. Zone redundant deployments using ERGW3AZ provide maximum availability across geographic locations. The AZ Network VPN Connection Create Command establishes circuit connections in each region. Connection weights and routing policies enable intelligent traffic distribution across regions based on latency and availability requirements. Cross-region connectivity leverages Azure's global backbone for inter-region traffic while maintaining ExpressRoute benefits for on-premises connectivity in each region. Advanced BGP policies. The AZ Network Route Filter Rule Create Command implements advanced BGP community filtering for granular traffic control. Custom community values enable complex routing policies across multiple circuits and regions. The community's parameter accepts multiple community values for sophisticated traffic engineering. Combining standard Microsoft communities with custom values creates hierarchical routing policies. The AZ Network Express Route Peering Update command applies multiple route filters per peering session. Dynamic filter updates enable real-time traffic steering without BGP session disruption. Advanced BGP implementations support conditional route advertisement, traffic load balancing, and service-specific path selection for optimal network utilization and performance. Bandwidth management. The AZ Network Express Route Update command modifies circuit bandwidth dynamically without service interruption. The bandwidth parameter accepts values up to the parent ExpressRoute Direct port capacity. The AZ Monitor Metrics List command retrieves bandwidth utilization metrics for capacity planning. Metrics include bits in per second, bits out per second, and packets in per second for comprehensive traffic analysis. The AZ Network Express Route Port Show command displays aggregate port utilization across all circuits. Real-time monitoring enables proactive capacity management and circuit optimization. Bandwidth scaling supports business growth scenarios while optimizing costs through right-sized circuit allocations and dynamic adjustment capabilities. The key difference between ExpressRoute Direct and standard ExpressRoute is the elimination of the service provider layer. With standard ExpressRoute, you connect through a telecommunications provider who manages the physical connectivity to Microsoft. ExpressRoute Direct gives you dedicated 10 gigabits per second or 100 gigabits per second ports directly into Microsoft's edge infrastructure. This means no shared bandwidth, no service provider dependencies, and complete control over circuit provisioning. Cost-wise, ExpressRoute Direct has higher upfront port costs but lower per circuit fees. The break-even point typically occurs around 5 to 8 circuits, making it ideal for organizations with multiple connectivity requirements. Performance benefits include consistent latency, dedicated bandwidth, and the ability to provision circuits on demand without waiting for service provider coordination. Regarding ExpressRoute Direct port utilization, the AZ Monitor Metrics List command retrieves detailed utilization metrics for ExpressRoute Direct ports. Key metrics include port bits in per second, port bits out per second, and line utilization for comprehensive capacity monitoring. Additionally, the AZ Network Express Route Port Show command displays current circuit allocations and remaining capacity. This helps with capacity planning and determining when additional ports or bandwidth upgrades are needed. To track trends over time, the query parameter can filter specific utilization data. Understanding utilization patterns enables optimal circuit distribution and identifies peak usage periods. Port utilization monitoring is critical for ExpressRoute Direct because you are paying for the full port capacity regardless of actual usage across circuits. Advanced Circuit Management. The AZ Network ExpressRoute Update command enables dynamic bandwidth modifications for circuits on ExpressRoute Direct ports. Unlike standard ExpressRoute, changes take effect immediately without service provider coordination. The AZ Network ExpressRoute Delete command removes circuits instantly, freeing capacity for other uses. This agility is a major advantage of ExpressRoute Direct over traditional provider-managed circuits. The AZ Network ExpressRoute List command with filtering shows all circuits on a specific direct port. This visibility helps manage circuit sprawl and optimize bandwidth allocation across multiple workloads. Circuit lifecycle management becomes much more dynamic with ExpressRoute Direct, enabling rapid provisioning for new projects and decommissioning for completed initiatives. ExpressRoute Direct MAC-SEC encryption. The AZ Network ExpressRoute Port Update command enables MAC-SEC encryption for ExpressRoute Direct connections. The MAC-SEC config parameter configures IEEE 802.1ae encryption at the Layer 2 level. The cipher parameter specifies encryption strength with options including GCM-AES 128 and GCM-AES 256. The Key Vault secret ID parameter references stored encryption keys in Azure Key Vault for secure key management. MAC-SEC provides wire speed encryption without performance impact, ensuring data confidentiality across the physical fiber connection to Microsoft's edge routers. This encryption layer complements existing application-level security and is essential for organizations with strict data protection requirements. ExpressRoute Direct Capacity Planning. The AZ Monitor Metrics List command with time series data helps analyze ExpressRoute Direct usage patterns over time. Historical utilization data informs capacity planning decisions and identifies growth trends. The AZ Network ExpressRoute Port Show command displays current circuit allocations versus total port capacity. This real-time view shows immediate capacity availability for new circuit provisioning. Capacity planning for ExpressRoute Direct involves analyzing peak usage periods, growth projections, and burst capacity requirements. The dedicated port model requires careful planning to optimize cost versus capacity. Planning considerations include circuit distribution across dual ports for redundancy, bandwidth allocation for different traffic types, and future expansion requirements. ExpressRoute Direct Troubleshooting Advanced. The AZ Network ExpressRoute Port Show command with detailed queries diagnoses physical layer issues specific to ExpressRoute Direct. The RX light level and TX light level fields indicate optical signal quality. The AZ Network ExpressRoute Show command reveals circuit-specific issues including provisioning states and BGP session status. Multiple circuits on the same port can have independent issues requiring individual diagnosis. The AZ Network Watcher Connection Troubleshoot command provides end-to-end connectivity testing specifically for ExpressRoute Direct circuits. This helps isolate issues between physical layer, BGP layer, and application connectivity. ExpressRoute Direct troubleshooting requires understanding both the shared physical infrastructure and individual circuit configurations that may affect specific workloads. ExpressRoute Direct Performance Tuning. The AZ Network VPN Connection Update command with Enable Fast Path optimizes ExpressRoute Direct performance by bypassing the virtual network gateway for data plane traffic. The AZ Network ExpressRoute Update command can modify circuit bandwidth in real time to match performance requirements. This dynamic adjustment capability is unique to ExpressRoute Direct. Performance tuning involves optimizing both individual circuit performance and aggregate port utilization. Load balancing across multiple circuits can improve overall throughput and redundancy. ExpressRoute Direct's dedicated infrastructure enables predictable performance tuning since you're not competing with other customers for bandwidth or processing resources. ExpressRoute Direct Cost Analysis. The AZ consumption usage list command provides detailed cost breakdowns for ExpressRoute Direct, including port fees, circuit charges, and data transfer costs. Understanding cost components helps optimize spending. ExpressRoute Direct port fees are fixed monthly costs regardless of utilization. Circuit fees are based on bandwidth allocation, making right-sizing critical for cost optimization. The break-even analysis compares ExpressRoute Direct costs against equivalent standard ExpressRoute circuits. Typically, Direct becomes cost-effective with 5+ circuits or high bandwidth requirements. Cost optimization strategies include circuit consolidation, bandwidth right-sizing, and leveraging the unlimited data option for high-volume scenarios. ExpressRoute Direct Automation. The AZ Network Express Route Create command can be automated for rapid circuit provisioning. ExpressRoute Direct enables on-demand circuit creation without service provider delays. ARM templates and bicep modules specifically for ExpressRoute Direct include port resource definitions, circuit configurations, and BGP peering settings. Template parameters enable environment-specific deployments. PowerShell scripts can automate routine ExpressRoute Direct management tasks including bandwidth monitoring, circuit provisioning, and utilization reporting. Automation is particularly valuable for ExpressRoute Direct because you control the entire stack from physical ports through circuit management, enabling end-to-end automated workflows. ExpressRoute Direct Enterprise Patterns. Multi-tenant scenarios use ExpressRoute Direct to provision dedicated circuits for different business units or customers. Each circuit provides isolation while sharing the underlying port infrastructure. Hub and spoke patterns leverage ExpressRoute Direct at the hub site with standard ExpressRoute or VPN connections for spoke locations. This provides centralized high-capacity connectivity with distributed access. Disaster recovery patterns use ExpressRoute Direct ports in multiple regions for geographic redundancy. Circuit failover between regions provides business continuity capabilities. The managed service provider pattern uses ExpressRoute Direct to offer dedicated connectivity services to multiple customers while maintaining isolation and performance guarantees. ExpressRoute Direct Summary. ExpressRoute Direct transforms Azure connectivity by providing dedicated physical ports directly into Microsoft's global network. This eliminates service provider dependencies and enables unprecedented control over hybrid cloud connectivity. Key advantages include instant circuit provisioning, dedicated bandwidth, flexible capacity management, and support for multiple circuits on shared infrastructure. Organizations gain agility while reducing complexity. Technical capabilities span from basic connectivity through advanced features like MAC-sec encryption, global reach, and sophisticated BGP traffic engineering for enterprise-grade implementations. The economic model shifts from per-circuit costs to shared infrastructure, creating significant savings for organizations with multiple connectivity requirements. Business value proposition. ExpressRoute Direct delivers measurable business value through reduced connectivity costs, improved operational agility, and enhanced performance predictability for mission-critical workloads. Organizations typically achieve 25 to 50% cost savings compared to equivalent standard ExpressRoute deployments while gaining operational benefits like instant circuit provisioning and dynamic bandwidth scaling. The dedicated infrastructure model provides performance consistency essential for high-throughput applications, real-time analytics, and large-scale data migration scenarios. Strategic advantages include future-proofing through scalable architecture, simplified vendor management, and the flexibility to adapt connectivity as business requirements evolve. Implementation recommendations. Start ExpressRoute Direct implementation with thorough capacity planning and clear requirements definition. Analyze current ExpressRoute usage patterns, growth projections, and performance requirements to determine optimal port sizing. Implement a phased approach beginning with pilot circuits for non-critical workloads before migrating production traffic. This approach validates configuration and performance while minimizing risk. Establish robust monitoring and automation from day one. The operational advantages of ExpressRoute Direct are maximized through automated circuit management, performance monitoring, and capacity optimization. Plan for growth by designing modular circuit architectures and implementing automation frameworks that support rapid scaling as organizational needs evolve. Next steps and action items. Begin with an ExpressRoute Direct feasibility assessment, including current connectivity analysis, cost modeling, and technical requirements validation. This foundation enables informed decision-making. Engage Microsoft and colocation providers early in the planning process to understand physical infrastructure requirements, lead times, and coordination processes for cross-connect installation. Develop an implementation roadmap with clear milestones, success criteria, and rollback procedures. Include testing phases, migration windows, and validation checkpoints. Establish a center of excellence for ExpressRoute Direct management, including operational procedures, automation frameworks, and ongoing optimization processes.